This session's ArcGIS Server Deep Dive for App Developers. Thank you all for coming. So one of the things I'll say is I've made the slides available. That's what that bit.ly link is. So if you wanted to write it down or take a picture, everything I'm going to show you today is available online. I'm presenting from that location right now. If you ever have any questions about anything that we cover in this session, feel free to email me. My email is on the slide. Before we begin, this thing's loud. Let me ask, this is for app developers. So most of this stuff is going to be fairly technical, app focused. Now I am actually not an app developer. I work on the ArcGIS Server team. I'm one of the leads on the ArcGIS Server and ArcGIS Enterprise team. So I'm going to be coming at this from an ArcGIS Server perspective. But I've had lots of conversations with developers as they've run into issues with ArcGIS Server. A lot of times they know just enough to get the app written, and then when they have to get into ArcGIS Server, they're like, well, I don't understand what's going on. So that was what prompted me to suggest this session, is to kind of give just enough information so that you guys can understand how ArcGIS Server is working and how to troubleshoot those issues. So this is not necessarily intended to teach developers how to administer ArcGIS Server. I'm not going to go into any administration. It's really to help you guys write your apps and get past obstacles that you run into. With that in mind, I've tried to make the session generic, so I'm not going to focus on any particular developer technology, though most of my samples are in JavaScript, simply because it's easier for me to take a screenshot of a web browser than it is for me to take it on my Android phone, for instance. Now, just to get a sense, how many of you guys, and you can raise your hand on multiple things, work primarily with JavaScript, just to get an idea? So a good chunk of you. How about the runtime for the .NET runtime? Yeah, Java runtime? A few people. Android, iOS? Okay. So I think this will be interesting to all of you. What I've done is I've organized it a little bit. The first section, I'm just going to talk about the tooling that I'm using and the methodology I'm using to try to troubleshoot problems when I see something from an app going into ArcGIS Server. Then I'm going to go in specific areas: web maps, printing, security, and editing. And I'll go in more in depth on those areas, or what's happening behind the scenes, so that you have an understanding of what your app is doing when you run into that problem. So this session, there's no bullet points in this session. My focus is primarily on showing you the developer tools and showing you the interaction that's happening behind the scenes. So with that in mind, I'm just going to dive right in. So the first thing to understand about when you're working with an app in ArcGIS Server is that all the communication between your app and the SDK and ArcGIS Server is happening through the network, right? So your app is a client, it's sending a request through HTTP, it's going to ArcGIS Server or portal, and it's responding. So the first place to troubleshoot in a lot of these cases, especially when it's not clear where the problem is to understand the interaction between ArcGIS Server and the app. A lot of times, I've found in the app or the SDKs, you may get an unexpected result, you may get an error, but you don't know why you're getting that error. You don't know why something didn't work properly. Sometimes ArcGIS Server sends back a message, and that message doesn't get funneled up or propagated up into the app or the SDK. So your best friend for troubleshooting ArcGIS Server problems are using networking tools. If you're working in JavaScript, it's really easy. You can just use the browser, and you can use the developer tools. If you're not working in a web browser, but you're working in a desktop application or a mobile application, you can still intercept the network traffic by using something like Fiddler. How many of you have used Fiddler at some point? Okay. Now, a lot of people don't know this, but Fiddler, if you use it on the same exact machine as your desktop, it can often intercept traffic with the browsers. But if you're using like .NET or Java, you may need to tell Java or .NET to use a proxy to a particular port. Fiddler listens on port 8888 by default. And so you can tell your runtime how to do that. If you're actually in that situation, send me an email and I can send you a link to how to set up Fiddler in your environment. They have a pretty good help topic on that. And if you're on a mobile device and you can't run Fiddler on the mobile device, you can still have your mobile device connect to a proxy as long as it's on Wi-Fi, connecting to a server or a Fiddler instance that's running there. Fiddler can be put into a mode where it accepts traffic from the outside. It's not on by default, but it can be used to intercept network traffic. Now in this particular case, I'm starting up the developer tools. I'm using something called Vivaldi. It's compatible with Chrome, but it has very similar developer tools as Chrome does. So I've gone to the network tab, and what you can see on here is all the URLs that the browser is using to fetch stuff from the internet is shown right here. So I've picked a particular URL request. It's highlighted. It's about 2/3 of the way down on that list. And then what you can see is on the right, there's a panel that corresponds to this request. And the first panel is headers. So I'm not going to go into a lot of detail on HTTP communication, but I'll give you a rundown very quickly of what happens, because it does help troubleshoot this. In HTTP, if you spy an HTTP request, essentially it's just based of properties and values separated by colons. So there's no binary format. It's not very hard to read. It'll say, for instance, there'll be a property, cache control, colon, and then there'll be max age or whatever the value happens to me. You obviously have to understand the spec to understand this stuff, but to write it, but a lot of times you can just read it. And that's what you see right here. These are the headers that you're seeing on this request. Below that is usually a body. That body will often contain either parameters if you're sending in input, or it can be just blank if there's no other information. Like on a GET request to bring back an image, there would be no body. The other aspect is the query string parameters are shown there. That's often part of a URL, that's part of the header, and that's often how parameters are sent as well. You can see these are set here. Now, after that HTTP request is sent, a response is immediately sent, and you can see that on here on the response tab. And all the responses from ArcGIS Server, for the most part, are in the JSON, the JavaScript object notation format. Now, as you can see, like on this example here, the JSON that's being responded is pretty hard to read. It's on a single line. It's just going off the edge. There's no hierarchy. And so probably most of you, especially if you've worked with JavaScript at all, have a favorite tool for formatting JavaScript. A lot of text editors or code editors will format the JSON nicely. If you don't want to install something, I go to jsonlint.com and I just paste in my JSON and I say validate. And then it turns that ugly JSON into something that's a little bit easier to read. If you do use JSONlint, just keep in mind that you're sending whatever you're sending across the internet. And so I wouldn't send anything that has sensitive information there. In this case, it's just an item from ArcGIS Online that doesn't have anything sensitive in it. So the next thing I'm going to explain is there's going to be a lot of network traffic that I'm going to be talking about in this request. Because I'm going to look at actual ArcGIS Server request. Now, because that can be a little bit hard to read, what I've tried to do is the convention I've followed on the upcoming slides is if it's something that's being sent to ArcGIS Server, that has the gold border. And if it's something that's being sent back from ArcGIS Server, that's in a purple border. I've also tried to put the things that are being sent on top and the things that are being received back from ArcGIS Server on the bottom, just because it seems to be a logical way to do that. Now with that, let me go into the web map deep dive. How many of you are familiar with web maps by this point? Probably most of you. Well, some people didn't raise their hand, so I am going to explain it, even though the other users will say I live and breathe web maps. Web maps are awesome. I love web maps. When we first started designing and coming up and implementing web maps as a spec and as a design 5 years ago, I was really excited about it because it eliminates the need to write a lot of code. Instead of writing code to say add layer such and such, set my extent to such and such, turn on this layer such and such, this is not interesting code to write. And it's not fun code to have to update when somebody in the office says, oh, I want that layer off by default. And you have to do another code deploy. that is just not fun. So it's really nice to have a configuration file that specifies which layers are in your map, which ones are on by default, what extents you have, and even sometimes what results or things are being highlighted on the map. So I think the web map is a great advancement in the way of developing GIS applications. Now, to understand how it works, there's a few things that go on. What I've done is I've just picked a sample application from the JavaScript API. It's live on the internet. If you type this URL in, you would see the same thing that I'm going to show you right here. Now, this code example, I think, illustrates why the web map is awesome. If you look on the left, you don't have to read the code, but that is the entire HTML file for this application. This is an application where you can zoom, you can pan, you can interact with the map and do interesting things. And if you even look at this HTML file, most of it is not code. The thing that I've highlighted in gold, that's the code. And then so I've blown that up on the right. And if you look at that code, even if you look at that code, a third of it is comments. So you're really seeing, which is equivalent of about 2 or 3 lines of code, you can get an interesting map to work in JavaScript. Now, in all of the SDKs, when you work with a web map, you give it an item ID, and that's what's in that red box. You can see there's this really long string, F2E9B, blah, 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 and that corresponds to an ID of a web map. Now, one of the nice things about the web map is that it's actually hosted in a portal. So it's hosted either in ArcGIS Align organization, or if you've installed a portal, it's in a portal. And so when your app connects to one of those, it can download the web map. And it's powerful and it's dangerous at the same time. It's powerful because if somebody needs to update that web map, the web map doesn't ship with the app. It can be updated and the app can download it, and it can work with the latest version of that web map. So if they wanted to change the extent, they wanted to add some layers to the web map, all the apps will now get the latest map right away. Obviously, the danger with that when you're coding is if you're depending on a certain layer order, layer 3, and now they've inserted something above it, now they've broken your app. So there is a challenge with working with web maps. And so a lot of times you will see people say, listen, I had my app, it was working great, and suddenly it broke and I don't know why. So I'm going to try to help you troubleshoot web map issues by understanding how the web map works, or how an app works with it. The first thing any of our SDKs will do is our SDKs will take that item ID and they'll turn it into a URL. So that's what you see in the gold. Our portal API consists of a content area and an item area, and then you put in an item ID, and it will come back with JSON. And that will tell it about the item. The first thing the SDK will do is it'll just confirm that the item it was given is a web map. Like it's expecting it to be a web map, but there's no guarantee that it actually is a web map. Maybe you typed it wrong. So it's going to get back that information. It's going to see it's a web map. It will get a title that could sometimes be turned into something that you show in your layer of contents or table of contents. And there's an extent that your application will use. So if you see things that are just like, oh, the extent's all wrong, it's showing you the wrong spot, it's wrong spatial reference, that stuff's all in the web map and you can view that. Once you get back this metadata about the web map and that your SDK has determined that it is a web map, it's going to actually get the web map. That first call didn't actually return the web map. There were no layers specified there. There was no symbology defined. All that stuff has yet to be defined. So it makes a second call. And that second call actually returns the web map. And that's a data call. It's that same item URL, but there's a /data at the end of it. And there's F equals JSON. Now this is important because if you go into Portal and ArcGIS Align, it is really, really hard to see this, what the JSON is for the web map. The whole map, as we call it, the HTML view of the portal and the thing, we don't show this to you. Whoops. So this is something that you almost have to go into our API to see the actual JSON that makes up the web map. And we don't document it very well. So when you take a look at this web map, you're going to open it up and you're going to see your operational layers. How many of you are familiar with the concept of operational layers? Okay, I only see about half the hand. So I'm going to explain this concept because this is a really important concept. Operational layers are things that your app and your users are going to interact with. They are things like the user may be able to turn off that layer. They may be able to identify features on that layer. That is the layer that you're working with. You can also have a base map layer. A base map layer is not something the user interacts with necessarily. It provides visual context. So in this example that I have from this app, it's showing accidental deaths. Accidental deaths is your operational layer. When you're looking at like the country boundaries, that's a base map layer. The user doesn't care about finding the square mileage of the United States when they're looking at accidental death. They're interested in knowing where the accidental deaths are. So you can see both of these URLs show up right here. The third thing you'll see on the bottom is the version for the web map. So all of our SDKs should handle new versions of the web map. So the web map has a version, we have a spec, and we can add things to it. All SDKs, when they see a newer version of the web map, should just ignore the features they don't understand. Because that we do introduce things. At one point we introduced time-based layers and gave information about those time-based layers. And if you were using a really ancient version of our JavaScript API, it wouldn't know what to do with it. It would just not show the layer. And that's expected. That's what you want to have happen. You don't want it to break. But when you look at things, when you're troubleshooting problems, it's important to understand what version of the layer you're working with. Now that it knows which layers are there, the first thing it does is it's going to go get the base map layer. Now most base map layers, especially the ones we host online, are map service tile layers. So our map services in ArcGIS Server, there's two kind of modes for it. One of them is the export map call. The export map call says, hey, map service, here's my extent, here's the layers I want on and off, and draw me an image. And it will go and it'll render that for you. It'll do that on the fly for you. That's an expensive call from a CPU perspective. I mean, in the grand scheme of things, it may take a quarter of a second to a half a second, but that's an expensive operation. The other type of map services in ArcGIS Server are tile map services. In that case, the administrator has generated a bunch of tiles. They may have spent 3 weeks doing that, but they generated a bunch of pre-computed images so that when your application went and said, hey, I need to take a look at this level of information, it'll send back a tile. The tiles are either 256 by 256 or 512 by 512 pixeled images. So in my particular case, my display is like a 1920 by 1080 resolution. So if I had 256 by 256 pixels, it's probably going to need something like eight tiles across and then 4 tiles down. So it might make a request for about 30 tiles in your application. So it's making a lot of those. And you can see like the little purple box there, that's what the tile might look like. It's just a small part of the map, and then in your app or your SDK, it'll glue it together. Then the next thing it will do is it will go out to those operational layers, and it will then place them on top and render them on top of the base map layers. In this particular case, the operational layer is a feature service layer. So what it's going to do is it's going to get information about that feature service layer. Now, one thing you guys hopefully don't have to worry about too much, though you may see it from time to time, is a feature service is not always a feature service. I mean, it's very confusing because we have a lot of different implementations of our feature services behind the scenes. We have feature services for data that you uploaded to your portal or online. Online has a different implementation than server. There's feature services for insights that are a little bit different than, so there's about 4 or 5 different types of feature services. And then feature services is one of our most fastest moving areas of our software. We're constantly iterating there, doing a lot of exciting work. The challenge is, because of this, feature services really need to communicate their capabilities to SDKs so that the SDK and the app know what the feature service is capable. So you'll see here on this display, you'll say, well, whether it supports calculate. Oh, yes, it does. Is the data version? Does it support truncate? Is statistics enabled? So all these things are communicated back by the feature service. One of the things, if you're initially developing something and you're trying to work with a web map or a feature service and something's not working the way you expect it to, It may be because your SDK is not letting you send the request because it knows something's disabled. This is something you can take a look at, is whether the feature service is supporting the particular capability that you're trying to use. The other thing is on that right smaller box, which is a continuation of this information, it also tells you how that feature service is going to be symbolized. The feature service is just going to send back some lat long points and some attribute information, such as, longs or strings. It's actually doesn't necessarily have a rendering. So it needs to send back that information. On this one, it's a very simple one. The render is a simple renderer, which means all features in this layer are all going to be drawn the same. We're not going to make some features bigger or some smaller in this feature class. It also gives it an image. In this case, it's a red circle. But you can see it right there in that image data. It has this long string of hexadecimal values, essentially, that are going to tell it how to draw that image. And then the client will be expected to draw it. We still haven't even got back the data yet. We know how to draw the feature service. We know which fields it has. We know what types those fields are, but we actually haven't got back the features. So then it sends this long request, which is going to return essentially all the features for that feature service up to 2000. At 2000, it will stop. And then it's going to get all this information and it's going to load it. Now, with the SDKs, our SDKs have a few models for retrieving feature services. There's this notion of a feature service retrieval mode. The SDKs are trying to solve two different problems. One of the problems is that you as an app developer you want fast performance. You're like, hey, I'm going to download this feature. I don't want to go retrieve that feature again. I want it cached because, boy, when I pan and zoom, I don't want to make another feature service call. Hold it. I just got it 3 seconds ago. It's not going to have changed. So the SDKs will hold on to stuff and they'll cache stuff. On the other hand, there's this competing interest from app developers. Listen, Amy down the hallway just updated that feature. Why am I not seeing it on my app right now live? So there's no right answer to this problem. The app developer has to make a decision as to what makes sense in their app with their data and their services. So in this particular app, it's a sample app. The data is not changing underneath the hood. And so it just pulls down all the data, caches it all. If there were a change, you wouldn't see it until you refresh the browser because it's caching these features. So I went through a couple scenarios with web apps that I occasionally see. One of them is I have a working app. It's been working fine. My users love it. But now it suddenly breaks. What's going on there? The first thing, if your app's just completely busted in some major way, it's usually not going to be, and it's not service specific. Well, the thing that's happened before this is it's the web map probably, right? It tries to retrieve the web map, and either the web map's not being returned, somebody deleted the web map, somebody updated the web map. I would definitely check, in this case, I said ArcGIS Server, I'll update the slides, portal responses for errors. Was there some kind of problem there getting the web map? And I wish I could detail the ways that it could break, but it can break in 100 different ways. Users are very creative in the way that they can break your app. Second thing, the updates aren't showing up. Well, there's two types of updates that might happen in your web app. One of them is with features and one is with tiles. So with these tiles for your map service, the person who administers your ArcGIS server and who publishes these services, they have control over how the tiles are going to be treated. So there's this cache control property in HTTP. A web server can say, listen, this content browser is not going to change or get updated frequently. Don't bother even checking to see if this has been updated for X amount of time. It could be an hour, it could be 5 minutes, it could be 2 days. With ArcGIS Server tiles, we do send back information on our map services saying cache this for a certain amount of time. That is controllable by the person who publishes their tile services. It's not often changed by people who publish tile services. I think we have a default of like a day. So if you downloaded a tile and then somebody just updated those tiles, your SDK, your app, may not be checking for updated tiles. And you're like, why am I not seeing it, but my coworker down the hallway is seeing it? Well, because they started their app after the update and yours is still cached. If you want more information, this URL here will show you and explain this operation. So you can send this to your ArcGIS Server administrator and they will know what to do with it if you think it's incorrect. For features, it's the feature response mode. And in JavaScript in particular, there's also a refresh interval. In the JavaScript API, you can say, listen, I want to download all my features when I start up, but you know what? Refresh every hour just to make sure I have the most recent features. And that will control some of the liveness and the caching of your features. The next area I want to go into is printing. Now I'll talk a little bit about printing. There's two models to printing. One of those models is that you could print in the client. Like you're in an app, you're on Windows or you're on Mac, and you're now looking at an app and you're seeing something on the screen. And you just want to click print and you want to send it to the printer. Well, if the client is just saying, I'm going to take these pixels, I'm going to send them to a printer, that's client-side printing. Client-side printing is actually hard to do in a lot of cases. If you want high cartographic quality printing, you want the scale bar to be accurate and properly represented its length on the field, given how many pixels there are, there's actually a lot of stuff to think about. A lot of the other option is to do server-side printing. In the server-side model, the client will send, and the SDK will send the job to ArcGIS Server. ArcGIS Server is built on ArcObjects, the same logic we have in ArcMap, really good at creating great printing output. And it will produce a PDF and send the PDF back, and the PDF will accurately represent what you're taking a look at. So in that second model of server-side printing, I'm going to talk about that one a little bit more. Like for instance, if you're doing JavaScript, you're always doing server-side printing. In JavaScript, you just don't have the kind of heavy lifting operations to do client-side printing really well. So the JavaScript API always relies on this. This sample is from our JavaScript API, and you can see some of the features of it. It kind of illustrates in a very basic way what you can do with printing. You can give it a title, you can specify an author, and when you set up your print service, you can specify things like whether I want a scale bar, a north arrow, a legend. All those things can be configured. Now, with printing, what happens is essentially, I don't have the request here. Well, I'll just explain it then. So what happens is it sends a request to the export map, the printing tools task, which is geoprocessing service in ArcGIS Server. It ships with every ArcGIS server, has to be turned on by an administrator. If you're using our JavaScript API in particular, it will often figure out, at least this print widget will, it'll figure out what your printing service is from your portal. So I'll go to portal, say portal, there's what's called the portal self call. It'll give it all what are called utility services, including the print service. And now you as an app developer can say, no, I want to explicitly put a URL in there. I want to go to this server, and you can override it. But by default, it will go to the portal. The portal will tell it what print service to use, and then your SDK will send it on to that print service and send on those parameters and then get back a response. So if you're using the print widget in JavaScript and you're finding that it's just not working at all, first thing to check is, are you even working with a portal at all? If you're not working with a portal, you must put in a print service URL. Second thing, of course, is if you are working with a portal, they may not have configured a print service, or they may have not turned on the print service for ArcGIS Server. If you're the first app developer who's doing printing, that's a high probability. Work with your ArcGIS administrators, it's a 10-second change. They click start this print service. By default, it's turned off so it doesn't consume resources on the server machine. Now let's say you've got it working, and now you are seeing errors. So the first thing is, if the print task is actually sending a request, so you got to pass the initial thing where the SDK is not even sending the request. Hopefully the response that you get back, looking at the network responses, will give you some idea as to what's wrong with that request. And then I already talked about the other case. If you're not even seeing it being sent, check whether the portal is a URL set. I forgot to mention this one. The other thing that often gets people is the HTTPS response. So for those who are not familiar with that, HTTPS does encryption, right? When the client, your browser or your app sends something to ArcGIS Server, it's going to encrypt it. But there is a lot of challenges with certificates and accepting of certificates in apps. I cannot tell you how many I get every week on this. So take a look at your HTTPS URL if you have one, and make sure that it works on a browser on your platform, because sometimes there just may be little issues with the HTTPS certificate. We probably could have a whole session just on that. Now, the other thing that you could see in the print service, this is probably what I even see more commonly, is actually you see your PDF come back, but then you see some of the layers are missing. There's a couple of things that can go wrong. So you and your browser are connecting to these services, but ArcGIS Server is over here. And when you say, ArcGIS Server, draw this for me, your web browser is not scraping those pixels and sending them to ArcGIS Server to draw. It's saying, here, ArcGIS Server, here's the URLs. ArcGIS Server is going to then go out to the same URLs, the same services that you're using client side, and try to connect to them. So I often see problems with ArcGIS Server trying to connect out to the services that your user is looking at. So what does it need to look out? A lot of servers are put into DMZs, firewalled off environments where they're just not allowed to randomly go out and connect. And it's a good precaution. Most web servers do not need to go out and connect to random stuff. Your email server waits for requests to come in. It doesn't need to go out and connect to random stuff. Your database server doesn't need to go out and connect to random stuff. Now, ArcGIS Server does have a need sometimes to go out and connect. So first thing to check, if you're not seeing layers being drawn, is make sure your print service can connect to services that are outside of your DMZ. A lot of times you'll see this if you're using, it may draw your operational layers that are coming from that same server because it's communicating internally, but you might see it has even problems connecting to the ArcGIS Online base maps. The base maps are not drawing, it's saying it's trying to go out into ArcGIS Online to get those tiles, and it just can't do it. The second thing is, if you do have a firewall, ArcGIS Server, you need to talk to your administrators on this, but it can be configured to use what's called a proxy server. You may not want ArcGIS your machines to randomly go out, but you might have a way for them to go out where they have to connect to a proxy and the proxy is allowed to go out. If that's the case, ArcGIS Server can be configured for proxy settings. The other one, and this is one that I get quite a bit, is sometimes it's connecting to an ArcGIS Server that has some form of authentication that the ArcGIS Server cannot provide. So a lot of times ArcGIS Server has what's called web tier authentication. Windows authentication is an example. Certificate authentication, a lot of times if you're in a highly secure environment, you have a card you got to put into your computer. You have to enter a PIN instead of a username and password. In these kinds of environments, the print service just doesn't have your card and your PIN. It can't connect to that web server. Those layers are just not going to work, unfortunately. There are some solutions that might be able to solve that, but you can set up resource proxies sometimes to solve that problem. Sometimes you can set up a secured credential service in your portal. If you actually encounter that situation, let me know. It's a hard situation. There's not always a solution. Now let's talk about security. So ArcGIS Server, its fundamental thing of interest is a service, right? And that's where permissions are applied. So by default, in the old versions of ArcGIS Server, every service was anonymously open, made a developer's life really easy. You never had to worry about security. You just went to the URL and the URL showed up. The world has obviously changed. There's hacks going on all the time. Even super secret organizations that are really strong on security are being hacked even in these days. So a lot of people are using security more, and they're securing their services. And so sometimes you have to troubleshoot these problems, and it helps to understand how security works with ArcGIS Server. In most cases, ArcGIS Server uses tokens to get access to something. Now, in a nutshell, tokens solve a problem. And the problem is this. If you had a very naive version of security, You might just say, listen, every time you need to access a URL, send me your username and password. You know, so on those calls where you said, hey, give me the information about that feature service, here's username and password. Now I want those features, here's username and password. Those tiles, here's username and password. You're sending those usernames and passwords a lot, right? It's like being carded all the time, every time you want to buy a drink in a bar if you're really young looking. That hasn't been a problem for me for a long time. But if you were in that environment, you know, they can give you a wristband, right? One person who's authoritative says, listen, give me your card. All right. They can put a wristband on, and then when you want to order a drink at the casino, you show them the wristband. They're like, okay, you've been checked out. Token works the same way. You get authenticated once, you give your credentials to ArcGIS Server, and it's going to give you back some string. And this string is something that's hard to tamper with, it's hard to fake. And then all the subsequent requests, instead of having to send your username and passwords all over the place and possibly risking its being compromised, instead you risk this token. And this token tells ArcGIS Server who you are. That token alone is enough for ArcGIS Server to know who you are and what groups you're in and what access you should have. So the first thing our SDKs do is a very optimistic approach. First thing they'll try to do is just try to access the service with no token. They're just like, you know what, I'm assuming the service is anonymous, and they'll give it a try. And then if it is secured, ArcGIS Server will come back with this JSON response saying, hey, token's required, you gotta send me a token. No problem, that's not really an error. Sometimes people see this when they're debugging things through Fiddler, and they're like, oh my gosh, there's this error. That's not necessarily a problem, that's very normal. That's an expected error. The SDKs, now that they know they need a token, this is what they're supposed to do next. They go to this REST info call in ArcGIS Server, and it will tell the client what kind of security is enabled and how it can get a token if token security is enabled. So on the line above the red box, it says, is token-based security enabled? And it says true. So then it goes to the next line, and there's a URL. This is the URL that the client's going to use to actually get a token. Now in the application, because it's token-based security, the app now says, you know what? I'm going to need a username and password. It looks like it's token-based. That means I, the SDK, am responsible for getting this information, or the app am responsible. And so the user's prompted, they enter their username and password. Now, what then happens is it makes that call to that URL specified, the token's URL. And you can see here in the second part of this request in gold that it's actually saying, hey, this is a get token request, and it's sending the username and the password. It also sends the expiration. So these tokens, they're only valid for a short period of time. You can't necessarily keep that token around for weeks and expect it to still work, because that token, it's being sent all the time. It could be compromised. You don't necessarily want that thing to be valid forever. The default for most short-lived tokens is 60 minutes. And that's what this JavaScript application asks for. It says, give me a token for 60 minutes. Now, it's not necessary for the token service to give you a token for 60 minutes. The administrator can say, listen, I'm in a highly secure environment. I don't want a token out there for more than 15 minutes. That's okay. Your SDK will handle that for you. Because in that response that you get back, you'll get the token, and then you'll get an expiration time. All of our times, you know, you probably have, if you've ever seen the internal communications with ArcGIS Server, I should also mention this. Almost all the times you'll see with ArcGIS Server have some crazy long number there. And these are milliseconds since the epoch, right? In January 1st, 1970. Date formats are different for every country, and so we don't try to put like 5 to 17, because is the 5 for May or is the 5 for this February 5th? So we always send back things in long integers, and so that's what we do here as well. So that's the expiration time. Now with that token, it then appends it to the request. So it's going to this feature service. This is the same feature service that earlier said, hey, you need a token. Now it's not a given that this token's going to work, because maybe you are allowed to log in, but you're not allowed to access the service. Maybe it hasn't been shared. Maybe the permissions are not correct. Now what you would see if it's allowed is you'll actually see the response that you expect. In this case, it's a JSON that describes the feature service. If this wasn't allowed, you would get an error response, just like the one that you saw 2 slides before, or 3 slides before. You would get an error and your code would be an authorization denied, saying basically that you don't have permission to that service. Now I guess the question is, there's a couple things that are in your favor in having to work with security. We used to actually have security sessions just for developers because it was such a complex area. But over the last few years, in most of our runtime and our JavaScript, we've introduced this concept of identity manager. And the identity manager, hopefully for most of you guys, takes away the grunt work of having to do security. You as app developers can focus on making great apps that are useful for your user and not have to worry about security. So a lot of this stuff gets done by the identity manager for you. But in the cases where something's not working, you do have to kind of understand this protocol and how to troubleshoot it. The other thing that I'll mention, so there's this authorization and token. And when you're going to be looking to see if a token is being appended. That's the first thing. So on a request, is the token being appended? Is the user being prompted for a username and password? And you're going to look for this sequence and make sure it's being followed. The other thing that trips up developers, like I said earlier, from a security perspective is HTTPS. Especially in JavaScript. If you're in some of the desktop applications, they're not as picky about this. But in JavaScript, there's this mixed content thing. Your app is running in HTTPS. And so the user sees this lock and it makes them think that this app is secure. If you go to Amazon, you're about to enter your credit card information, you're looking at that green lock to make sure that that credit card I'm about to enter isn't going to be sent clear text over the internet. That's a scary thought. So most browsers will enforce this, that if you're about to send something behind the scenes, so-called AJAX request, that it's not going to be allowed to go over HTTP. Because that's a violation of the user's trust. They're expecting, and it probably as an app developer, you don't mean to do that anyway. You're not going to send a credit card over HTTP clear text. So the browsers will prevent certain requests from occurring if the communication channel is not over HTTPS. The app's at HTTPS, so you've got to go get content, your services at HTTPS. The place where you'll run this into as an app developer is a lot of times, a lot of organizations, government organizations, they've been sharing data and they've been doing it for years, but their server is only available on HTTP. They just don't even support HTTPS. So sometimes you'll add a layer to a map, even be a web map, and you just don't see the layer show up. And that may be because you are in a secure environment, you're showing the app at HTTPS, and the moment it tries to make an HTTP call, especially with feature service editing, feature services have to use those AJAX requests, you'll see things fail. So unfortunately, there's really no solution. It's a browser imposed thing. The only solutions are either you've got to allow your application to be run at HTTP. That may not be something in your control. Or you may need to talk to the web server owner, the person who's running ArcGIS Server, and say, hey, got to enable HTTPS so that we can use your service. But you may not know who to contact for that, and that may also be out of your control. We as Esri have been trying to get all of our customers to use HTTPS just for security reasons. The default on our product changed about 4 or 5 releases ago, so if you installed new, you had to go to extra effort to disable that. So hopefully over time you'll see less of those problems. I think the last area I want to cover is editing. So here we have a simple editing app. And you can see that all over the app we have a bunch of points. I've selected a particular point and I'm about to do an update on it. Now what happens behind the scenes for this? I think there's a couple things you have to understand with editing apps. And with feature services in general. The first is worth noting is it's getting information about the feature services. And I talked about those capabilities. I said, does it support calculate and all those other things? Probably one of the most important properties for you as an app developer is this one, which is use standardized queries. I don't know if you're aware of this. If you've been programming with our SDKs and our APIs for a while, you may have known this at one point. Prior to, I think it was about 10.2 when we got this change in. Prior to 10.2, when you made a query to ArcGIS Server, you needed to know which database was powering your feature service because the syntax varied. So if you were querying a feature service and it was using SQL Server, you might write your where clause differently than if you wrote your where clause against an Oracle database. And that kind of worked at 9.2 and 9.3 because, hey, I'm developing an app for my own organization, and I know I'm the DBA and the developer, and I'm the ArcGIS Server guy. That model didn't work so well when people started sharing this stuff on the internet. I don't know what the U.S. Geological Survey is using for their database. I don't even know who to ask. So at 10.2, we introduced this notion of standardized query, and we turned it on by default. We just said, hey, listen, if you're going to use services in ArcGIS Server, we're just going to have a standardized where syntax. And it was the same syntax that we used with our own file geodatabase. It's going to be some standard SQL stuff, and you're not going to have to know what database that they're using in the back end to do a query. Now, in this case, the standardized queries is false. So this database here, you actually have to know kind of what's powering this server to know what kind of query it is. So if you see, for instance, in your app that a where clause is failing unexpectedly, check the feature service metadata for this uses standardized queries. You will only see this property even exist on 10.2 servers or later. If it's 10.1 or prior, it is not, and you need to know what kind of database it's using. So that's the first thing that can throw you in this. I think the second thing to know when you're doing feature service editing is this notion of templates. How many of you are familiar with feature templates? Just a smattering of people. In some sense, it works automatically, and so sometimes it just automatically works for a lot of people, but sometimes you have to understand it as a developer. So when you author a map and you're a layer, what you want is, we wanted an easier way to edit. So the idea is I should just be able to drop a point on a map, have something pop up and ask me the basic information about the thing I just added to the map. If I'm adding a fire station, well, I want to know what fire station number it is. I want to know which fire department it's with. I may not ask a lot of other questions, but also I may want to pick a standard symbol for that. And it may even be based on the input I entered. If it's the Riverside Fire Department, maybe I symbolize it differently than I do the San Bernardino County Fire Department. But the point is, these templates describe how features look. When you publish a map service to ArcGIS Server, that is embedded in the MXD, the feature service template. And this information is automatically generated. There's a default. And when you edit and you're using feature templates, these things have like defaults for you. So if you don't specify something, then the default value is used, because in a lot of cases, yeah, you don't want to ask a user for 20 different fields. Sometimes the defaults are just fine. So if you see things unexpected on the edit, you're like, where did that come from? Yeah, one of the things to check is the templates. A lot of times you can't go check in ArcMap the original MXD and figure out what the settings were on that templates. This is the best thing that you can get in terms of what these values are. The third thing, of course, is the capabilities of the feature service. So not every feature service can be edited. So the capabilities here tell you exactly what can be done. Can it be created? Can it be deleted, queried, update, and deleted? Now then, once it has information about this service, it's going to, and you've actually had the user make the edits, then it's going to call the apply edits call in most cases. There's some other calls that feature service supports for updating features. Apply edit seems to be the one that's used most often. And in it, you'll see here's the JSON, or sorry, not the JSON, well, it is the JSON, but it's the request form. It's saying, here's the update. I want to add this point, X, Y. Here's the spatial reference, attributes, and then the information the user entered, like in this case, incident address. So it's just throwing this up and it's sending it for an edit. If you're seeing, the one thing that is, hopefully you'll see most of the time is, if there is a problem, hopefully it will tell you what the error is. Now the response is important to understand. It's a little bit tricky, because if you think about this, a lot of times you don't want to do a feature by feature edit. That's not efficient. So if the user updated or added 20 features, you don't want to know that there was 20 calls made to ArcGIS Server. That's just incredibly slow. Just send it as a batch. Now that's great for performance. It's a little bit harder to debug, because what will happen is when you send a batch, we actually respond for each individual item that was added. So if you try to add 20 features, In the one response, we're going to have an individual response for each feature that you attempted to add, and we'll tell you whether it was successful or failed, so that you have an idea of which feature failed. Now, I don't know, who knows why the feature failed. Maybe the right data wasn't sent, or you left something null that was required, but at least you can identify which feature it was. A lot of times, first thing I see people say is, well, my edit failed, and I don't know why. And yeah, because you have to be able to identify which feature it is. And so you'll take a look at the request and then correspond the response. Now in this case, you see the request has an FID of 419, and then you'll see in the response it says 419, this edit succeeded. So in this case, we were okay. But if something had failed, you would then know which feature it was, and you could go look at the actual edit that was made and try to understand why it failed. With that, I think perfect timing. So at this point, I want to make a request that you guys fill out the evaluation. This is the first time we've offered this course or this session. It's also, I'm not a professional presenter. I work on the development team. So I really appreciate feedback, and I'll take it constructively. If you have suggestions about content or presentation skills, please put it in the app. I would love to hear about it. If you loved it, also put that in there. That helps me too. Know if I'm doing something right. Second thing is we'll take questions, but before we do that, here's the slide. For those who walked in late, everything I just showed is on this link. You can just go to this bit.ly link, and it will take you to the slides that we saw. They're just Google Slides. And the other thing is, if you ever want to email me, you have a question about anything in here, feel free to send it to me. My expertise is with ArcGIS Server. I can answer most questions about ArcGIS Server. I may not know a lot about JavaScript app or JavaScript app development or .NET development. I've done it, but I'm not a pro. I also have my cards up here in front. If you just want to take a card, you can take that to go. And with that, I'll just open it up for a few minutes of questions. Maybe I should ask the audience questions. Maybe we should do like a pop quiz. Well, if nobody has any general questions, then what you can just do is come up to the front, and I'll be happy to answer them. Thank you very much.